Hello class, and welcome to our part 2 of our notes on scale drawings. Again, our standard is still 7.G.1. This is the second part of our notes, so make sure you've watched the first video before watching this one. And we're going to begin right up with teacher example 3, pencils down. A scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model? So what we're trying to do is we're trying to create that original fraction or that original ratio that we made that we were given in examples 1 and 2. So now we actually have to find that. So what we want to do is we want to start by saying the model, which is 10 inches, over the actual, which is 100 feet. Then we want to go ahead and reduce our fraction. So as you can see here, we have model height over actual height, 10 over 100, 1 inch over 10 feet. Now hopefully you remember that you cannot remove the units. And hopefully you remember why, and that is, if you get rid of the units, that means you're saying they're the same. And here you can see we've got inches and feet, which are not the same units. So our answer would simply be the scale is 1 inch to 10 feet. Now the second part is where we're looking at getting rid of the units. What is the scale factor of the model? Now remember, that's when the numbers are written without units. So we either need to convert inches into feet or feet into inches. The important part here is whenever we're working with scale factor, the numerator is always 1. So what that means is we don't want to change this 1 inch. We want to keep it as a 1. So that means we need to change our denominator. So if for every foot there's 12 inches inside of it, that means we need to multiply 10 times 12 to see how many inches in total there are in 10 feet. So we have 1 over 10. We multiply 10 times 12 and we get 120. So that means our scale was 1 inch over 10 feet. Our scale factor is 1 inch over 120 inches. And hopefully you remember that with scale factor we don't use units, so we cross off the inches and we just have 1 to 120. The scale factor is 1 to 120. Notice we can write it sideways or we can write it up vertically as a fraction. Either answer is correct. So I want you to go ahead and try this problem out on your own. A drawing has a scale of 1 millimeter to 20 centimeters. What is the scale factor of the drawing? And my hint to you here is just a reminder there are 10 millimeters in 1 centimeter. So for every centimeter you're going to have 10 millimeters inside of it. So go ahead and try this out. Remember, you can always go back to teacher example 3 to get a little refresher. You're going to set it up exactly the same way. Okay, let's go ahead and look at our scale factor. Now notice they've already given us the scale, 1 millimeter over 20 centimeters. We don't have to do that part. All we have to do is get rid of the units. Because the numerator is already a 1, we want to leave that one alone, and we want to turn 20 centimeters into millimeters. So if in every single centimeter there's 10 millimeters, we are going to multiply 20 times 10 and we find 200. So that means our scale factor is 1 to 200. Okay, so notice this one was a little easier because we didn't have to find the scale, we were already given it. Okay, let's go ahead and go on to example 4. This is our final example, and again this one is tricky, so make sure you're really paying attention. The scale drawing of a computer chip helps you see the individual components on the chip. Find the perimeter and area of the computer chip in the scale drawing. Now, notice the scale here, drawing versus actual, 1 centimeter is equivalent to 2 millimeters. So that means the actual computer chip is much smaller. We've enlarged it so we can see it better. Just like in Miss Vanko's science class, you're going to enlarge a lot of the images that you're working with so that you can actually see it. So we want to find the perimeter and the area of the computer chip in the drawing. So all we have to do here is measure. And I've already gone ahead and measured with my ruler, and I found that each side length is 4 centimeters. It's a square. So to find the perimeter, of course, I add up all the sides. 4 plus 4 plus 4 plus 4. And to find the area, I square the sides, so 4 squared, or 4 times 4. I find out that they are in fact the same. The perimeter is 16 centimeters, 4 plus 4 plus 4 plus 4, and the area is 16 square centimeters. Be careful, remember that area is always squared. If you said answers are both 16 centimeters, you would have your answer incorrect. So be very careful. The area is squared, always. Okay, now for the tricky part. Find the actual area and perimeter of the computer chip. Now, what you have to do here is you have to go back to the side length. You're not going to work with the perimeter and area. Back to the side length and convert that first. So we can set up our fractions. 1 centimeter over 2 millimeters is going to be the same thing as 4 centimeters over x millimeters, or s in this case. And cross multiply. 1 times s is s, 2 times 4 is 8. So the side length of the actual is 8 millimeters. Now I can find my perimeter and my area. For perimeter, I do 8 plus 8 plus 8 plus 8. And for area, I do 8 squared, or 8 times 8. So 8 plus 8 plus 8 plus 8, which is the same thing as 4 times 8, is 32 millimeters for the perimeter. And the actual area is 8 squared, 64 square millimeters. Again, remember, you need that square in there, and you can use the little 2, your exponent, or you can write the word square. Either way, it won't change your answer. So remember, to find the area and the perimeter of the actual, you need to go back to the side length, find the side length of the actual, and then you can find the area and perimeter. So I'm going to go ahead and have you try this one out. Remember, it is tricky, so go back to example 4 if you need a refresher. In this problem, we have exactly the same situation. However, instead of 3 millimeters, 1 centimeter is equivalent, or instead of 2 millimeters, 1 centimeter is now equivalent to 3 millimeters. So what if the scale of your drawing of the computer chip is 1 centimeter to 3 millimeter? How does your answer change? Explain. Watch out for this explain. You do need to explain why your answer changed and how it changed. So go ahead and review Part A and Part B. Part A, remember you're finding the perimeter of the drawing. Part B, and area. Part B, you're finding the perimeter and area of the actual. Go ahead and press play when you're ready to see your answer. Okay, let's go ahead and check Part A. First off, notice my drawing. It's exactly the same drawing. So hopefully you were able to realize that the size of the drawing would stay the same. So your answer to Part A would not change. So my answer would simply be the side length is 4 centimeters, the perimeter is 16 centimeters, and the area is 16 square centimeters. Nothing changes in Part A. Part B is where you have the change, because what I need to do first is I need to change my side length. So I need to set up my proportion. 1 centimeter over 3 millimeters equals 4 centimeters over x millimeters. I cross multiply, and I find that 4 times 3 is 12 millimeters. Now that I have my new side length, I can find the perimeter and area. To find the perimeter, of course, we do 12 times 4, because there are 4 sides to the square. To find the area, we're going to do 12 squared, or 12 times 12. So my actual perimeter would become 48 millimeters, and the actual area would become 44 square millimeters. I don't know where my little 2 went. There should be a little 2 right there, my little exponent. It seems to have disappeared. Okay, hopefully you were able to get both of those correct, and have a great day.